Hey, algebra friends, we are looking at section 12.1 and we finished this problem already. We were given this, I'm just kind of giving us a little bit of an idea of what happened. Our answer was x is equal to 2, and this is example 3. Let's move on to example 4. Again, we are still dealing with inverse relationships, y varying inversely with x, which we know we can write in this way. Y is equal to some k over x. Here we're given an example for that y varies inversely as x when y is equal to -6. Look at me replacing y with -6 and then replacing x with 9. And then so now we're supposed to find this information out. And we're going to get there, but what we need to do here is organize this so that it informs what the general inverse variation we have. So when I do that, when I solve for k, because that's what I need, I'm going to multiply both sides by 9. And I get that k has to be, these guys cancel, k has to be equal to -54. And so y is equal to -54 over x. And so now that we've established a relationship that y and x have, now we can look at this. Find y, so I'm looking for y, when x is equal to 6. So -54, 54. Okay, -54 over 6, which is x. And then when I do this, I get that y must equal -9. Not too bad, right? So y is equal to -9 when x is equal to 6. This final problem of the section will probably remind you of a seesaw, and it's the idea, the physical idea of the way the weights relate. You ever sit on a seesaw with somebody that's heavier than you, or see this actually enacted? The person that's heavier would have to go further inside in order to balance the weight of somebody lighter. They'd have to go further away from the lever or the fulcrum, that thing that is balancing the two weights. All right, so let's check out what's happening. It says the weight and the distance multiplied have to equal the weight and the distance multiplied on the other. So the distance from that lever point, or the point of the fulcrum, the distance has to, when multiplied with the weight, has to equal the distance on the other side when multiplied with the weight. I've babbled that. Let's go ahead and read the problem. So when two objects are balanced on a lever, their distances from the fulcrum are inversely proportional to their weights. In other words, the greater the weight, the less distance it should be from the fulcrum in order to maintain balance. If an 8-kilogram weight is placed 1.8 kilometers from the fulcrum, how far should the 12-kilogram weight be placed from the fulcrum in order to balance the lever? And so we see that we're dealing with the product rule, I believe we called it earlier on. The weight 1 times the distance 1 has to equal to weight 2 times the distance 2. It's kind of like the ordered pairs x1, y1, x2, y2. So in this case, we know that 8-kilogram weight will be placed 1.8 meters away from that lever, from the fulcrum, and then a 12-kilogram weight needs to be placed how far? And so we're not sure what d sub 2 is, and so we're going to calculate that. So we end up with 14.4 when we multiply 8.8 times 1.8. We get 14.4 is equal to 12. We divide both sides by 12. And I'm a little mad at myself that I pulled out a calculator, because this is like 144 divided by 12. We should get 12, but we get 1.2 because that's how it is with decimals and stuff. Sorry, guys, for not being your mathematical leader of awesomeness. But 1.2 meters from the fulcrum is the distance that we're going to have to put the 12-kilogram weight. And I hope that all of this made sense. All the stuff we talked about in this second little part of the video and in the beginning part. So we're dealing with hyperbolas. I wish that was a part of our vocabulary. Not a big deal. We're dealing with hyperbolas. We're dealing with inverse variation. And we see that when we have these graphs, we're going to get that kind of an H vibe. And then we have like something like that, right? We'll get something of that nature, usually not cutting that way, but we'll talk about it. Look, guys, let me know if there's any questions. I look forward to talking to you soon. And please take care. Bye-bye.